On the morning of the 23rd of October 1942, a German reconnaissance pilot flew low over the desert south of El Alamein, counting British vehicles massed for Montgomery's offensive. His report, filed at 0847 hours, noted approximately 600 lorries and supply vehicles in the southern sector, precisely where the British wanted him to look. What he couldn't see were the 1,200 tanks and self-propelled guns positioned in the northern sector, each one disguised beneath layers of Hessian netting, chicken wire frames, and sand-encrusted canvas that made them appear, from 500 feet, to be nothing more than ordinary 3-ton lorries. The deception worked. When the barrage opened at 21:40 hours that evening, the Panzer Army Africa was caught facing the wrong direction. Its reserves committed to defend against an armoured thrust that didn't exist, whilst the real punch came from a sector they dismissed as merely a supply concentration. This wasn't sophisticated technology. British soldiers were covering million-pound Churchill tanks with agricultural chicken wire purchased from Egyptian merchants, smearing them with a paste made from sand, petrol, and whatever adhesive they could scrounge, then draping the whole assemblage with nets that would have looked more at home on a Grimsby trawler. German forces, meanwhile, were employing factory-manufactured camouflage systems designed by aeronautical engineers, scientifically tested under controlled conditions, produced to exacting standards. Yet throughout the North African campaign, from Crusader in November 1941 through to the fall of Tunis in May 1943, it was the British improvisations that consistently deceived Axis aerial reconnaissance, whilst the superior German systems often failed in desert conditions. The paradox seemed complete: agricultural materials and soldiers' fieldcraft defeating industrial precision and scientific rigour. But this wasn't a victory of amateur enthusiasm over professional expertise. It was the triumph of design philosophy purpose-built for chaos over systems engineered for control, and the difference between those two approaches lay in understanding what deserts actually do to equipment and what aerial reconnaissance actually sees. Standard military thinking in 1940 emphasized laboratory-tested camouflage systems. The German approach, refined through the Spanish Civil War and the Polish campaign, relied on printed canvas covers manufactured to specific patterns. Each vehicle type received purpose-designed tar nets, camouflage netting, produced in factories to match particular deployment theatres. For North Africa, this meant tan and brown geometric patterns scientifically calculated to break up vehicle outlines, when viewed from standard reconnaissance altitudes of 800 to 1,200 metres. The system worked brilliantly on proving grounds in Bavaria. Italian forces employed similar factory-produced covers, their patterns designed by artists who'd studied desert coloration in Libya during the 1930s pacification campaigns. British doctrine initially followed the same path. War Office Manual, AFV Training Volume 2, 1939, specified that camouflage netting should be manufactured to approved patterns, issued through normal supply channels, and applied according to precise instructions to ensure uniform appearance across formations. The theory was elegant. Standardization meant quality control. Factory production ensured adequate supply. Approved patterns guaranteed effectiveness. Critics of field improvisation argued that untrained soldiers would create detection hazards through inconsistent application, that agricultural materials would lack the durability of military specification fabrics, that the whole enterprise would descend into chaos. They were right about the first part. British field camouflage in the Western Desert was inconsistent, with techniques varying wildly between units, between vehicles in the same squadron, sometimes between opposite sides of the same lorry. What the critics failed to anticipate was that this very inconsistency would prove far more effective than the uniform precision they prized. The secret was in understanding aerial recognition psychology and desert environmental conditions simultaneously, two factors that laboratory testing couldn't replicate. When a reconnaissance pilot or photo interpreter examines desert terrain at scale, the human brain isn't primarily looking for specific colour matches. It's searching for patterns, regularities, and geometric shapes that indicate human presence. A perfectly uniform camouflage net, even if colour matched to desert sand, creates a consistent texture that reads as artificial against the chaotic, fractal complexity of natural terrain. British field camouflage exploited this cognitive reality through controlled randomness. The basic system, evolved through desperate experimentation during Operation Crusader in November–December 1941, worked like this. First, construct a frame from whatever rigid material was available. Chicken wire was ideal because its hexagonal pattern disappeared under coating whilst providing structural integrity, but units also used expanded metal mesh, spare track links, or wooden frames covered with hessian. Second, stretch the frame over the vehicle, creating a shape that disguised its actual outline. A 27-ton Crusader tank, 19 feet 8 inches long, could be made to resemble a 3-ton lorry, 15 feet long, by building a chicken wire frame that squared off the sloped glacis plate and added a vertical cab structure. Third, and this was crucial, coat everything with a paste mixed from local sand, used engine oil or petrol, and whatever binding agent could be found. Flour paste, glue scrounged from workshops, even blood from the butchered livestock that supplemented rations. The paste served multiple functions that factory-produced covers couldn't match. Mixed fresh for each application, it perfectly matched the specific sand colour of that particular position, and Libyan desert sand varied from pale cream near the coast to reddish tan 20 miles inland to grey-brown in the rocky Jebel regions. The oil or petrol content made it slightly reflective when fresh, exactly matching damp sand in early morning when reconnaissance flights typically occurred. As it dried over hours or days, it aged through precisely the same colour shift as the surrounding terrain, from darker when damp to lighter when dry. No factory could replicate this automatic environmental matching. What actually mattered was that the paste created genuine three-dimensional texture. Factory netting, being fabric, lay smooth against whatever surface it covered. From above, particularly in the flat lighting of midday, this smoothness read as artificial. The sand paste coating on British frames, applied by hand with trowels, brushes, or simply thrown on and smoothed, created an irregular surface with tiny variations in thickness, random clumps, and organic-looking lumps. When photographed from reconnaissance altitude, this texture caught light and shadow in patterns indistinguishable from the rock-strewn desert surface, but the decisive advantage lay in how these systems degraded. German tarn nets, being manufactured fabric, wore uniformly. After 3 weeks in desert conditions, with daytime temperatures reaching 115 degrees Fahrenheit and sandstorms that could strip paint from vehicles, the printed pattern would fade evenly, creating a consistently lighter shade that no longer matched anything in nature while still maintaining its geometric regularity. British sand paste camouflage degraded chaotically. Sections would flake off, new sand would adhere, wind erosion would create random patterns. The whole assemblage would take on the weathered, neglected appearance of equipment that had been sitting unused for months. To aerial reconnaissance, this read not as camouflaged enemy equipment, but as abandoned junk not worth photographing. The reality of combat showed this difference most dramatically during Operation Bertram, the deception plan for 2nd Alamein. Between the 26th of September and the 23rd of October 1942, XXX Corps conducted history's largest camouflage operation, transforming the entire northern sector whilst creating phantom formations in the south. The key technique: sun shields. A sun shield was a chicken wire and hessian frame, 19 feet long by 9 feet wide by 7 feet high, designed to sit over a Grant or Sherman tank and make it appear, from aerial reconnaissance, to be a 3-ton lorry. Each frame cost approximately £3 in materials: chicken wire at 2 shillings per yard, hessian at 6p per yard, wooden battens scrounged from packing crates. Construction took a 4-man team roughly 6 hours. By comparison, a German Tarnets for a comparable Panzer IV cost 180 Reichsmarks, approximately £15, and required factory production. Lieutenant Colonel Charles Richardson, Montgomery's chief deception planner, later wrote, "The genius of the sunshield lay not in its sophistication but in its utter mundanity." German photo interpreters had seen thousands of British 3-ton lorries. They expected them in forward areas. That's where logistics happens. A sunshield didn't need to be a perfect disguise. It just needed to be boring enough that an interpreter, examining hundreds of photographs under time pressure, would categorize it as supply vehicle and move on. The numbers proved the concept. Between the 1st and 21st of October, the 1st and 10th Armoured Divisions, 476 tanks total, moved from reserve positions in the rear to forward assembly areas in the northern sector. Each tank drove forward at night, parked in a pre-surveyed position, and by dawn was covered by its sunshield, carefully coated with sand paste to match surrounding terrain. Simultaneously, in the southern sector, dummy tanks, wooden frames covered with Hessian and painted canvas, costing under £1 each, were positioned to simulate armoured formations. These dummies received minimal camouflage because they were meant to be spotted. The real deception was in the north. Luftwaffe reconnaissance flew 32 sorties over British lines between the 1st and the 22nd of October. Photo interpreters noted significant supply build-up in northern sector and armoured concentration south of Ruysat Ridge, precisely backwards. When interrogated after capture on the 4th of November, Hauptmann Wilhelm Steidler, intelligence officer of the 21st Panzer Division, stated, "We knew the British would attack. We knew they would mass armour for the breakthrough. Our aerial reconnaissance was excellent. We had clear photographs of their entire front. We placed our reserves to meet the armoured thrust from the south. When the barrage began in the north, we thought it was a diversion. For 6 hours, we thought it was a diversion. That 6-hour delay in committing reserves, because German commanders couldn't believe the northern attack, was the main effort given what reconnaissance had shown them, contributed directly to the eventual Axis collapse. The 15th Panzer Division, positioned to counter the phantom southern thrust, took 11 hours to redeploy northward on the night of the 23rd to the 24th of October, arriving piecemeal and exhausted. By then, the 9th Australian Division had secured the northern shoulder of the breakthrough, and British armour was exploiting beyond the original minefields. This wasn't accidental. British camouflage doctrine, revised after painful lessons in 1941, explicitly rejected the German emphasis on standardisation. Major Geoffrey Barkas, who commanded the Middle East Camouflage Unit from March 1941, was a film set designer in civilian life. His September 1941 memo to GHQ Middle East stated, "Factory-produced camouflage assumes controlled conditions and standardized viewing circumstances. Battlefields aren't film sets. Light changes hour by hour. Sand color varies mile by mile. Enemy reconnaissance photographs from different altitudes, different angles, different times of day. Any camouflage system that looks identical at dawn and dusk, from 500 feet and 1,200 feet, in direct sun and overcast, is a system that's trying to match an average. And averages don't exist in nature." Barkas's solution was to establish small camouflage units at divisional level, typically 1 officer and 30 men, often drawn from theatrical professions or art schools, whose job wasn't to apply camouflage but to teach soldiers how to make their own. The syllabus focused on principles rather than patterns. Understand what reconnaissance is looking for, match your specific local terrain, use materials that weather naturally, make it look boring rather than invisible. Training included exercises where soldiers camouflaged vehicles, then studied photographs taken from light aircraft to see what aerial reconnaissance actually revealed. The contrast with German practice was stark. Luftwaffe reconnaissance training emphasized identifying specific vehicle types by shape and shadow patterns. German photo interpreters learned that a Crusader tank casts a distinctive triangular shadow from its low turret, that a Grant's hull-mounted 75mm gun creates a characteristic protrusion, that British supply lorries park in regular formations. British camouflage specifically targeted these recognition patterns. Sunshields eliminated the distinctive shadows by changing the vehicle's apparent shape. Sand paste filled in the Grant's hull gun sponson. Units were ordered to park supply vehicles randomly, rather than in neat rows, because German interpreters associated regular spacing with active operations whilst irregular parking suggested abandoned equipment. What made this work wasn't any single feature, but rather the recognition that camouflage operates on multiple levels simultaneously. At the macro level, it's about matching terrain patterns and breaking up regular formations. At the micro level, it's about creating texture and weathering that reads as natural degradation. At the cognitive level, it's about exploiting what photo interpreters expect to see, and what they'll dismiss as unimportant. Factory-produced systems could optimize for one level, but struggle to address all three simultaneously. Field improvisation, precisely because it was inconsistent and degraded unpredictably, succeeded at all three without trying. The choice of materials revealed deeper engineering wisdom about desert conditions. Chicken wire, properly called hexagonal wire netting, manufactured from 20-gauge galvanized steel with 25mm hexagonal mesh, possessed several properties that made it ideal for desert camouflage frames. First, structural rigidity. The hexagonal geometry created a shape that held its form even when coated with wet sand paste, unlike rectangular mesh which tended to sag. Second, durability. Galvanized coating resisted corrosion despite constant exposure to sand, heat, and moisture from the paste. Third, invisibility. Once coated, the wire pattern completely disappeared, leaving only the texture of the paste visible. But the crucial property was thermal. Metal mesh, unlike solid fabric or wood, allowed airflow whilst maintaining shape. Desert temperatures regularly exceeded 110 degrees Fahrenheit during daylight hours. A solid camouflage cover over a vehicle created a heat trap, making the interior uninhabitable and potentially damaging equipment. German tar nets, being tightly woven fabric, created this exact problem. Crews often removed them during daytime because working conditions underneath became intolerable. British chicken wire frames coated with sand paste that formed a porous, broken surface allowed sufficient air circulation that vehicles could remain covered continuously. This wasn't a trivial advantage. Removing and replacing camouflage daily meant the netting was off during early morning and late evening, precisely when reconnaissance aircraft typically operated to exploit long shadows and optimal lighting. The sand paste formula evolved through experimentation. Initial attempts used pure sand and water, which dried into a weak powdery coating that abraded away within days. Adding petroleum products, used engine oil or petrol, provided binding strength and water resistance. The typical formula, by mid-1942, was approximately 5 parts sand to 2 parts water to 1 part oil, though units adjusted proportions based on available materials and local sand characteristics. Some formations added cement dust when available, creating an extraordinarily durable surface. The 7th Armoured Division's workshops experimented with adding burlap fibres to create a paste that could be formed into 3-dimensional shapes: fake rocks, mock equipment, landscape features. The logistics were impressively low-tech. Sand was obviously unlimited. Oil came from routine engine changes. A single tank company, maintaining 52 vehicles, generated approximately 200 gallons of used oil monthly, more than sufficient for camouflage paste. Water was the limiting factor in many positions, but the paste required far less than alternatives like washing vehicles clean before applying pattern paint. Chicken wire and hessian were purchased locally through Egyptian and Libyan merchants, paid for from unit funds or simply scrounged. When commercial supplies proved insufficient, units salvaged materials from abandoned Italian positions or cannibalized damaged equipment. This supply independence meant camouflage could be maintained without burdening the formal logistics chain. A tank regiment preparing for offensive operations received ammunition, fuel, rations, spare parts, and water through established supply lines that were already strained to capacity. Camouflage materials came from separate sources, paid for from petty cash, or acquired through barter. In practice, this meant camouflage maintenance never competed with operational priorities. It happened in parallel, using otherwise wasted materials, during downtime that would exist anyway. German forces expected professional military systems implemented by doctrine. Instead, they encountered what amounted to theatre-level stagecraft executed by soldiers who'd learned through trial and error. The difference manifested in unexpected ways. When the Afrika Korps captured British positions, they typically found camouflage materials stored with the units, rolls of chicken wire, bags of sand paste mix spare hessian, indicating that maintenance was continuous and locally controlled. By contrast, when British forces overran German positions, camouflage netting was stored centrally at brigade or division level, indicating it was issued for specific operations then returned to supply for inspection and repair. This decentralization had profound effects on innovation. Soldiers experimenting with local materials discovered techniques that formal doctrine would never have approved. The 2nd Royal Gloucester Hussars found that mixing sand paste with flour and meat fat created a coating that dried flexible rather than brittle, remaining intact through desert temperature cycling. The 4th Indian Division's workshops developed a technique for heat-forming chicken wire over wooden mandrels, creating reusable frames shaped like specific vehicle types. The 51st Highland Division discovered that coating hessian with paste, then crumpling it whilst wet and allowing it to dry, created a texture that perfectly mimicked desert scrub vegetation. These innovations spread laterally through informal networks, soldiers talking in canteens, workshops sharing techniques, units copying methods they'd observed working for others. By 1942, entire informal supply chains existed. Egyptian merchants in Cairo, who specialised in procuring chicken wire for British units, workshops in Alexandria that manufactured preformed sunshield frames to standard dimensions, even enterprising soldiers who'd established small businesses producing sandpaste mix in bulk and selling it to units in forward areas. The cultural contrast was significant. German military culture emphasised following correct procedures and trusting official systems. British military culture, at least in the Desert War, had evolved to accept that official systems were chronically inadequate and that survival required improvisation. This wasn't unique to camouflage. Units routinely modified vehicles, manufactured unofficial spare parts, and developed tactical techniques not covered by doctrine. Camouflage simply represented another domain where official inadequacy met soldier ingenuity. What's remarkable is how long it took German intelligence to understand what was happening. Even after Alamein, after-action reports attributed the deception to superior British reconnaissance security and effective signals discipline, rather than recognising the camouflage effectiveness. Captured German intelligence summaries from November 1942 describe British camouflage as crude but adequate in desert conditions, without recognising that crude was precisely the characteristic that made it effective. The blindness was partly technological. German aerial photography in 1942 was superb: Zeiss optics, professional film processing, skilled interpreters. But that very excellence created vulnerability. Photo interpreters were trained to identify vehicles by their technical characteristics, dimensions, shadow patterns, distinctive features. British camouflage specifically targeted these identification methods by changing apparent dimensions, eliminating distinctive shadows, and adding boring characteristics that triggered not worth further analysis responses. But the deeper failure was philosophical. German doctrine assumed that military systems should look military, organised, standardised, professionally executed. British improvised camouflage looked civilian, chaotic, almost amateurish. German interpreters saw this apparent amateurishness and concluded the British weren't particularly good at camouflage, that their systems were make-do expedients rather than proper military equipment. This assessment was technically accurate but strategically wrong. The expedients were working better than proper equipment precisely because they looked like expedients. The lesson extended beyond camouflage into fundamental design philosophy. Military equipment faces a choice: optimize for controlled testing or optimize for chaotic deployment. German equipment, from tanks to aircraft to camouflage, typically optimized for the former. It performed superbly under ideal conditions with proper maintenance, correct materials, and trained operators following procedures. British equipment optimized for the latter. It worked adequately under terrible conditions with improvised maintenance substitute materials and exhausted soldiers doing whatever kept things running. Neither approach was inherently superior. They represented different answers to the question of what working meant. German Panzer IVs with proper maintenance and factory ammunition could outfight Shermans in direct engagements. But Sherman crews could keep their tanks running on scavenged parts, non-specification fuel, and improvisational repairs that would horrify German engineers. German tarnets looked better on inspection and photographed well for training manuals. British sand-paste-covered vehicles looked rough and ready, but deceived the reconnaissance that actually mattered. In the Desert War, where supply lines stretched thousands of miles, where sandstorms destroyed precision equipment, where replacement parts took months to arrive, design philosophy optimized for chaos proved more useful than design philosophy optimized for perfection. Camouflage simply made this principle visible in the most literal way possible. British soldiers covering expensive tanks with agricultural chicken wire and sandpaste, creating deceptions that consistently defeated sophisticated enemy reconnaissance, whilst their opponents deployed scientifically tested factory-produced systems that looked professional but failed in the field. This wasn't anti-intellectualism triumphing over expertise. It was different expertise, the expertise of making things work under terrible conditions rather than the expertise of making things work under controlled conditions. And in war, controlled conditions are what you're trying to create for yourself whilst denying to the enemy. Equipment that only works after you've already won the battle for controlled conditions isn't actually helping you win that battle. Equipment that works whilst conditions are still completely chaotic, that functions during the desperate scramble before either side has established control, that continues operating through the fog and confusion and random chance that defines actual combat. That's the equipment that determines who eventually gets to impose controlled conditions. The British soldiers covering their lorries and tanks with sand and chicken wire weren't rejecting military professionalism. They were embodying a different kind of professionalism. The knowledge that battlefields reward what works in chaos over what looks good in calm. Their improvised camouflage, rough and ready and never standardized, consistently deceived an enemy whose professional systems expected professional opposition. That expectation was the vulnerability, and exploiting it required nothing more sophisticated than sand, chicken wire, and the genius of soldiers who understood that sometimes looking amateurish is the most professional thing you can do.